So I'm going to post the skill review with the answers in it so that the answers are not a mystery for you. But what I want you to do is, on your own practice and fill in and submit it. But what's the work? How do I get? So uh, what I want you to do is here are the questions. Find the function for the following, and I give you this information here. Here's the answer for it. What you want to do is, how do I go from this, f of 2 is equal to -3 and f of 4 is 5. How do I go from that to that? That's the thing you want to fill in the gaps. And so let me kind of just briefly, let me get your input real quick so that you can kind of get going. How do I go from here to here? What's the steps? Walk me through it. Well, let me do this. Find the linear function at that. Find the linear function. And when I tell you it's a linear function, by the way, what should you be thinking? You should be thinking, when it says linear, you should be thinking line. And when you're thinking the equation of a line, you're thinking y equals mx plus b. Okay, so this question here, even though it appears in the functions and the linear function section, it goes back to something we did a few weeks ago on finding equations of lines. So how do we find equations of lines? Takers? Anybody?
Y equals mx plus b.
Sure. But what do we do? So that's the first thing. So what do we need? We need to know what is m and what is b. So m is first. How do you find m?
The slope.
It is the slope. Yes. So what do we need in order to find the slope?
And x coordinate. Oh, I'm not quite sure.
Remember, there's a couple different ways. We're going to tell you either it's a horizontal or vertical line. We're going to tell you two ordered pairs, or we're going to tell you it's parallel or perpendicular. So which of those three scenarios do you, or we tell you what the slope is. Here, remember in the last review set, I told you what the slope was. It was like slope is -5 and goes through this other ordered pair. But in this one, I'm not telling you what the slope is. So either I give it to you, I tell you it's horizontal or vertical, I give you two ordered pairs, or I give you it's parallel or perpendicular. So which of those four scenarios do we have? I don't tell you it's horizontal or vertical. I don't tell you it's perpendicular or parallel. And I don't tell you, I don't give you the slope. So the only option left is two ordered pairs. So how do I, so that's what you want to do is when you're asked to find the equation of a line or you're asked to find the linear function, just we kind of go back to that process, that 5-step process we talked about. The very first thing is you have to find that slope. And those are the four ways you find a slope. So go through, and that's what you want to catalog and say, okay, which way do I have? Horizontal, vertical? Do they tell me it? Is it horizontal, vertical, two ordered pairs, or parallel or perpendicular? So the only one that fits here is they give me two ordered pairs. And that's the thing. That's what I'm asking you. I'm asking you to take that and also pair it with your function stuff. What are the two ordered pairs? Remember, functions are of the form f of x equals y. So line it up. F of 2 equals -3. That is telling you that the x is 2 and the y is -3. So when you want to write an xy ordered pair, one of them is 2, -3. Do you see that? Anybody in class? Oh, can you hear me? I'm checking.
Yeah, I did part of this lesson today, and I was kind of I was kind of happy with how much I remembered from it. So that was pretty good. I kind of liked the lesson.
Okay. So what's this? What's the ordered pair created by this statement?
Is it two and negative three?
That's one of them.
Two being the x,
Hmm. That's one of them.
and
And what's
one.
it's so what's the ordered pair created by this one right here? This f of 4 is 5.
Oh, x and negative five. I'm sorry, x and five. I'm sorry, four. Yeah, I'm getting tongue twisted. Four and five.
Right. There you
Four
go.
being the x, and
So we have two ordered pairs, 2 comma negative 3, and the second one. So this information here, the f of 2 is negative 3 and f of 4 is 5, it gives you two ordered pairs. That's what you need to draw from this is, oh, that gives me ordered pairs. Now I use the process from a couple weeks ago. I have two ordered pairs. I use that to find the slope formula, y2 minus y1 over x2 minus x1, and then I use y equals mx plus b to help me find the b value. So that's the thing I'm trying to. It incorporates all of that lesson. So this will be the answer here. So your task is to fill in the gaps. How do we go from here to the answer? Because that's what you're going to have to do on the test. So look at problem number 2. Determine whether following is a function. I'm telling you it's not a function. Why? Why? Where does it fail? Anybody? How do we determine whether something is a function or not? If you're looking at a graph, the way that you tell that it's a function is you do the vertical line
vertical
test.
line. Yes.
But if you're not looking at the graph, you're looking at a set of ordered pairs like this. How, by looking at a set of ordered pairs, do you determine whether it's a function or not?
Is it if there are two x coordinates that are the same?
Right.
Or
So do we have two x coordinates that are the same? I'll leave it to you. The answer is no. So yes, there are two x coordinates that are the same. What is the x coordinate that repeats? I'll admit it's kind of a trick question. So, but when you see
The
it, you're gonna.
3 and negative 3, because that's the only number that I see repeating. 3.
Well, those are two different numbers. Remember on the number line, 3 is over here and negative 3 is over here. They're in two different spots. So those are different. Those are different. There's another reason. I'll let the mystery percolate. Okay, so this one here says use the function f of x equals 3x squared minus 2x plus 1. Evaluate the following f of negative 2. So talk to me generally. What do I do for this? Anybody?
Everywhere you see an X, you replace it with negative 2.
Yeah. So we see an x here, we see an x here, and so you will want to indeed plug in the negative 2 for x. So good. So you should get 17 when you do that. Yes, you do. Okay. Domain. We're looking at function still. We want to be able to find the domain. Looking at this function, 3 over x minus 1. Now, when you visualize this it looks like this. I put the x plus 1 in parentheses to indicate the entire thing is in the denominator. So how would you articulate that? Well, I'm telling you what the domain value is. It's all real values that are not equal to 1. Why is 1 not in the domain?
because the denominator cannot and one minus
It sounds like you cut out right there. So yeah,
I
you're
think
looking at
that
the. So yeah, I think you may have just cut out. Well, let me fill it in for you. So right, the denominator cannot be 0. So we look for what values of x will make this thing 0, and we chuck it. We get rid of it. So yes, that's it. Good, 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 good. And then finally,
So,
Sorry,
mhm,
sorry. I figured out number two. It's four. It's 4 and 4.0. I
boom.
figured it out.
That's the reason. They're the same thing, 4 and 4.0. And I could do the same thing. I could put 4 and then I could put 4 over 1. They look different, but they're really the same thing. And that's the whole point. I want you to also kind of have that flexibility with numbers. Okay, and then the final one, determine the domain and the range. How do we, so here's the function again. Now I modified it a little bit. I said 4.1 so that it would make a function. So how do we go about it? So when you have something like this, a set, just ordered pairs, how are you going to find the domain? What's the process for finding the domain? I guess we already did this one. What would you say?
oh, it's all the numbers in the for the x coordinate.
Yeah, it's the x's. 0, 4,
So,
-3, 3, and 4.1. Right. And so the range is just the y values. 2, 2, 2. So there's only two different values. Now, what I may do, I'm gonna mess this up a little bit. I'm gonna change it up before I post it. So let me do this. Being that I did this one for you, I didn't mean to do that. I'll leave it blank, and you fill in now the domain and the range. I'm going to do this. Six, and then -3. Can I do -3? I can do -3. And then I'll do what? Pi. Okay, there we go. Now I just switched it up. So just kind of a quick review as well. Suppose I have the following graph. Now I can't draw graphs easily, so I'm not going to do it here. But suppose I have the graph here, a graph, and it's going to be, let's say, it's going to be this. For this one right here, for the graph right here, the pink graph, what's the domain and what's the range? What would you say the domain is? What are all the permissible x values? And remember what we do there. Left, right. What's the leftmost value? What's the rightmost value? What would you say?
0. So the domain and the range will both have a 0, right?
Well, so ask yourself, in this graph, how far left can I go? How far left?
Right. If there are no numbers, it's kind of hard to tell unless you just want to say infinity.
What does the arrow mean?
Oh, that it keeps going.
Keeps going which way? It looks like it's pointing
Uh,
up. It looks like it's pointing up. True. But remember, the horizontal
no,
direction, it's moving this way.
so less. Right. So negative.
Negative is
Negative infinity.
right. So the
Negative
domain
infinity.
starts at negative infinity and works our way all the way to what?
Positive infinity.
Positive infinity. Right. So you have to just that it's looking at the arrows. Good. What about the range? Remember the range is lowest, highest. It's the lowest value.
0.
0. Do we include or exclude 0?
Uh, include.
Yes.
I'm actually not sure. Okay.
Because there's a dot. There's no open circle or no
Right.
and
Oh, that's right. I forgot about the open circles and the dots and
mhm.
stuff. Okay.
And how about the highest value?
Would that be infinity as well?
That would be infinity. There you go.
Uh,
So when you have a graph, you can also look at it. Be mindful of that process: leftmost,
yeah.
rightmost, down, up to find the domain and the range. Okay,
Right.
so I'm going to post this
Hmm.
for you all to do. You've got the answers, just fill it in, and that's just part of your review process. But the point of this is to and to show you the answers too is I don't want the answers to be the mystery. so that you can sort of work with it and say, oh, here's how I find this, or here's what I do. That's sort of the point of the whole exercise. So let me load it right quick. And I'm not gonna let me do this. And I don't want to make it arduous. I mean, the point of it's not to be arduous. It's to be um, um, to help you review. It truly is a skill
Yeah.
review. So let's do function linear
Yeah.
functions. Let's do this. Some more options. Let me do this. I'm going to upload it.
Hmm. And Mr. Halverson, when you get a chance, can you remind me what when do we use those fancy brackets? You know the one I'm talking about, the squiggly ones? I completely forgot. I was trying to figure it out today.
That's when you want to write something as a set. But you
Okay.
shouldn't really need to use that because I think they give it to you in Hawks. They give you the squiggle brackets, so you're not going to have
Okay.
to
Yeah.
insert those yourself. Okay, so let's.
Okay, cool. So ordered pairs like an X and a Y, that would be just regular parentheses, and then a set, would that be like, okay, the domain, all the numbers in the domain, do they go in the squiggly bracket?
It could, or you can write, if, or like that graph we did, it could be like an interval.
Yeah. Okay.
So
That's
let me do this. Let me share with you. Okay, so it's loaded now. You'll see you'll see a skill review. I put it for Saturday. I mean, I'm not pressing much for it. Skill review functions, what we just did, just fill it in. But the point is, we're gonna end tonight at 6 p.m. Take the 30 minutes to do it, to do the skill review, just to fill it in and submit it. Get your 100 points. And I know I got to go back and review and grade the other ones, so I'll do that shortly as well. Um, and Jackie, I owe you some stuff too. So just a quick recap. You're not going to see it published here yet because I haven't published the test yet. But just to where are we at? Just to just a reminder, it's going to cover every. Whoa, hold on, hold on, hold on. I can't get my pen to work. Okay, so it's not showing. So it's everything from 2.R.1, 2.R.1, all the way down to 3.2, all the way down to 3.2. The linear functions. The linear functions. I'm going to save the quadratic and all that stuff for the rest of it. We may or may not have another test before the final, because I don't know if that would be the best use of our time, uh, because we don't have that much time. But then too, I can capture those last few questions on the final exam itself. So it's kind of doesn't. I've never really liked the idea of having a test and then having the final. It doesn't really. That's just me. It's philosophical. But here, this is a good chunk of information to have a test on because it kind of all goes together. Equations of lines, system of equations, and the beginnings of functions. Um, so take a look at that other skill review because the questions that I posed are exactly the skills you need. The questions may look a slightly different, but nonetheless, finding the slope, working with horizontal vertical lines, finding the intercepts, parallel perpendicular, finding the equation of a line, systems of equations, substitution and elimination, and then working with functions, finding the domain, the range, and then evaluation. That's a lot in and of itself, and that's why I don't want to. It's been a while. We can even see it's been a while since we've had a test. It's been what, coming on 3 weeks. So that's a long time in my 3 weeks. That doesn't sound right. Maybe less than that. Anyways, uh, but 3 weeks I think, and so that's a long time. Okay, so any questions before I move forward? Okay, so what we want to start doing here in this material, we're going to start manipulating functions. We're going to start manipulating functions. Uh, transformations of functions, and basically that's just sort of taking the shape, the general. We talked about the general shape of functions yesterday, the kind of functions that you'll have for what does a linear function look like? What does a quadratic function look like? That's the u. What is the cube function? The x cubed, x to the third power. That's an s, a snake. What is the absolute value? That's a v. Things of that nature. So what we're going to do is we're going to look at transformation and then properties of functions, and then here, this material is sort of cool because what we're going to do is we're going to start treating functions like numbers. You know how you can add, subtract, multiply, and divide regular numbers? Well, that's what we did with polynomials too. We add, subtract, multiply, and divide polynomials. That's where we did all of our rules of the distributive property, combining like terms, FOIL, rational expressions. That's add, subtract, multiply, and divide polynomials. We can do the same thing with functions. We can treat them like numbers too. Add, subtract, multiply, and divide functions. But the cool thing is that's all the rules that you did earlier of polynomials and working with numbers. It's not new stuff. It's just it's taking the old stuff and putting it in a new kind of a new outfit on, if you will. So let's take a look at 4.1 and 4.2 to get us going here. And transformations really is what the name is. It's transforming a function, transforming. But it's usually transforming from something that is known already. From something that is known already.
And by function, you mean like g of x and whatever?
I'm sorry, you're cutting out, Addie. Say it again.
Sorry. By function, you mean g of x? I'm sorry, f of x.
F of x, g of x, anything with this sort of notation here of something in x. F of x, g of x, w of x, whatever they want to call it. Right.
Thank you.
Okay, so here they want you to determine the more basic function that has been shifted, reflected, stretched, and compressed. So what we're doing is we're taking a function, let's say the graph of a function. Let me do this. We're taking the graph of a function, okay? And so suppose I have something like this. Just the traditional. This is the quadratic function. This is the function f of x. Let me do this. This is the function f of x equals x squared. But what I can do with that function is I can stretch it, I can compress it, I can reflect it, I can turn it over. So I can do things like this. I can stretch this function, take the ends and just pull them out. You see that? I'm compressing. It's just a big old long sweeping U. That's stretching. I can compress it. I can bring them together. I can take these arrows and bring them together. That's compressing it. Or I can also reflect it. I can reflect it. So in this case, reflecting would be something like this. Let me do blue. So I can reflect it this way. Okay. But if you notice, all of the shapes have the same general U category, the U shape, okay? So the basic function is f of x equals x squared. That's the basic function, f of x equals x squared. That's what that's asking, okay? What is the basic function? So you don't have to write the function, you just have to identify what's the basic one. So here, what would the basic function be? What are we trying to do? Well, the giveaway here is this part. The basic function is the x cubed, because that's when you expand this, if you were to do FOIL to this whole thing, expand it out, and how could we expand it out? To expand this would mean we take minus 7 minus x and we multiply it with itself 3 times. Okay? Do y'all see how I got that? Minus 7 minus x 3 times.
Yes.
because remember, this is the exponent of 3. So it says, give me 3 copies of that. Give me 3 copies. And so here are the 3 copies. If you were to do FOIL to this whole thing, you would get something, 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 but at the very end of it, you would get x cubed. Why? Because you have x times x, which is x cubed. So the basic function is f of x equals x to the third. That's the basic. They don't care about all the numbers. What does it actually equal? 21 minus x, 14x squared minus x cubed. They don't want all that. They just want at its source, what's the basic, what's the parent function? What's it all coming from? And that's what they're saying here. So the quick way to sort of look at it is, well, okay, I'm taking x and I'm raising it to the third. Or the long way is to say, well, let me apply FOIL and what's the basic one? So let's do another one just to sort of show you what they're looking at. Okay, so here's another one. uh, it says graph the original function based upon the more whether it's shift, reflected, stretched, or compressed. Okay, so uh, let me do this. I think there's something, there's online graphing tools. Let me see. Yeah, x minus 3 to the third. Look at that. You can go to you can Google online graphing calculators or online graphing tools. Type in your, do y'all see that? You can type in your function and it'll give you the graph. Are y'all able to see my screen?
Yeah, yes.
Okay.
Yeah.
So that'd probably be the best way to go about doing this. My recommendation.
Yeah.
Uh, Go ahead. And so here we see what's and then what you do is you compare it. You compare it. So over here, this is the base function right here. This is the base function, f of x cubed. And so we see that this is the defining feature. If you notice, it's crossing through the origin. Over here, it's shifted. Over here, it's shifted a couple of places. So there's a horizontal shift to the right. I don't see a vertical or anything compression, so I don't see a vertical stretch. I don't see it being stretched out. It looks the same, so I would say none. Is it reflected? And reflect if you were to reflect this, basically this moves to the other side, and this arrow moves to the other side. So it would look like this. I don't see it reflected, so no. I don't see reflection about the x-axis. I don't see reflection, so that's no. And if it were reflected around the y-axis, you're flipping it this way. I don't see that either. So it's those sort of things. So go to an online graph, just Google anyone you want, and then compare the graphs and see if you have this shifting, reflection, compression, or anything like that. That's probably the way I would go about doing it, because there are a good number of rules you could learn. I don't think it's worth our while. I'm not going to really test on that other than to maybe that question of what's the base function I would do, but otherwise, no. So the one that I went to, by the way, is this website. Oops. Looks like desmos.com. So let's do another one. Let's do the square root. Oops. So let's do the uh, square root x minus 4. And there it is. Or x plus 4. Or 2x, something like that. It's pretty cool. So go to this desmos.com slash calculator if you like it. I think this is a pretty cool one, personally. Okay, so determine the more basic function that's been shifted. This is the same sort of thing. This is actually the same question as the last one. So let's do x third. Yep, see. So it's the same thing as before. you have the exponent of 3 on the outside, so the x is going to be raised to the third power. That's a kind of a quick way to do it. Okay, identify the more basic shape. And this sort of builds upon what we did yesterday. What is the basic shape for this one? What's the function? What would you say? Does anybody remember? Well, this is a parabola, so the basic shape corresponds to x squared. This one here is the cubic function, and that one corresponds to f of x as x to the third power. And this one here, you may or may not remember, but this is what we call a hyperbola. The name doesn't matter. But this corresponds to what? F of x equals 1 over x. It's a rational expression. Rational expression. So, of the three, oh, there's more. There's more down there. So make sure you capture that if you needed to. Oh, I'm recording, so I think we're good. Yeah, I am recording, good. So then let me scroll down. This one right here is the square root of x, f of x. This one here is f of x equals 1 over x squared. That's the base function. And then this one here, this last one, is f of x equals the cube root of x. The cube root of x. So this one's x. So this one's x squared. This one's x cubed. This one is 1 over x. Then you have 1 over x squared, square root of x, cube root of x. Those aren't all of them, but we also, the only other one we didn't do was the v. That's the base one. So that's what they're asking for, is to connect the base function with the graph. So which one does this one? So now we go to this problem here. Well, this is an x to the third. So that's this one right here, x to the third. So this is the answer right there. That's how you go about doing it.
Can I ask a question?
Mm-hmm.
Okay, so can you bring those graphs back up so I can tell you which one I'm talking about?
Yeah.
Okay, so because they both appear to do the same thing, why is the one to the top right 1 over x and the bottom left 1 over x squared when they both have that little swoosh and kind of go out indefinitely?
Where is it? This one?
Yep.
See, what happens is, so think about what happens with 1 over x, okay? So this one goes like this. So basically the difference is this part right here, okay? So why is that? Is because when x is negative, let's take a look at the difference between 1 over x and 1 over x squared. So when x is negative, okay, negative. So let me put in a negative value here. -3, okay? What's the y value? It's 1/3, okay? I'm sorry, -1/3. So it's negative. So when we plug in f of -3, we get our y value is -1/3. So it's a dot like right here. But if I do f of -3 down here, what happens to the value? Because it's squared, 1/3 squared becomes positive. So it shifts across this. And that's what happens is all your negative values flip across on this part of it. It's the function. So that's the reason is in 1/x when you plug in a negative value, you get out a negative value, and that's why you have all your negative values down here. But in the 1/x squared, because of the feature of the x squared, it turns it positive. It basically says, okay, throw it back up above the x-axis. It's positive. So that's what we're saying. Does that help?
So 1/x squared could not be that same exact diagram, but at the bottom, like going, from left and then going down the Y?
It could. It could. We could have
Okay.
it like this too,
Okay.
but it would look like this. This is -1/x squared,
Okay.
but it's still x squared is the base function.
Okay.
When both of the arrows are swooping up, or they're both of them swooping down, that's 1/x squared. Does
Okay.
that help?
Um, a little.
A little. And so the key, let me go see if I can find it wouldn't give me the same answer again or the same questions again. And some of this may just be more memorizing or having the note. I don't know why it's not doing that.
Yeah.
Okay, there we go. Is the difference between our positions here is I've had plenty of practice to memorize all the different shapes, and I can make the connection real quick. It's a little more challenging on your end because you don't have that level of experience. I'm not asking you to do that. That's why I'm sort of giving you here's the pattern for each because it's not something that I'm really interested. I don't think it's sort of interesting to know, but I'm not going to invest. I don't think it's worth investing a whole lot to break down and go through it all. Uh, I think my computer's moving slow. So let me throw this one. What's the base function for this one? What's the base function for this one?
Like the f of x?
Mm-hmm.
Or- um,
F of x
Well,
equals what?
the design part is isn't that the vortex, the V? Wait, hold on, I have it drawn somewhere.
Yeah, let me go ahead and give you the answer. The base function is that absolute value. The absolute value. When you see a V like this, a sharp V, that's absolute value. That's in contrast to if you see the soft swooping U, the swooping U, that is x squared. The swooping U, the parabola, is x squared, whereas the sharp V is absolute value. Absolute value. See if it'll give it to me again. No, it doesn't want to do that. Okay, so this one here, okay, this one here, notice it's x squared. X squared is in the bottom. So this one, the base function is 1/x squared. Just to kind of give you a heads up. You look at the exponent over x, and then you look at the position. Is it in the numerator, denominator, things of that nature? Okay. So that's pretty much what they've kind of keep doing on this one. So just to give you a heads up on that, let me look at the next one. Okay. Properties of functions. This is pretty interesting too. Let me check with you all. Can you hear me okay on your end? Take this off.
Yes.
Okay, good. I'm getting a note. My computer's throwing me a note that it doesn't like what I'm doing. so let me see. I think I need to do something here. I'll do it in a second. Let's see. Okay. Great. I think I'm using up. It doesn't like what I'm doing. Do this. There we go. Okay. So let's take a look at some properties of functions in this sort of an interesting, weird way of saying it, but what do we mean by properties? And so this goes more to looking at the function itself and how does it look when we graph it. When we graph it. Oops. Oops. Okay, I'll do that. So, and oftentimes what we're interested in is like lines of symmetry. So if I were to graph this one right here, this thing right here, it looks like this. It looks like that. An upside down V. So they're asking, determine if the following equation has x-axis symmetry, y-axis symmetry, origin symmetry, or none of these. Okay, so what does that mean? So basically it says, so just to remember, remind yourself, the horizontal axis is the x-axis. So basically take the graph and fold it along the x-axis. So bring the top and the bottom together. Is the graph symmetrical about the x-axis? If I were to take it like my piece of paper here and fold it along the x in the middle, would it be symmetrical? And what would you say?
No.
I say
No.
no.
It is no. It is not. It is not x-axis symmetry. So that's a no. So now we do the same thing with the y-axis. Take it and bring the left and the right half together along that black vertical axis. Would it be y-axis symmetry?
Yes.
Yes. Yes, that one it does. So that's what they're asking. That's what they're asking. Is it symmetrical about the x-axis, the y-axis, or the origin itself? So that's what they want to do. So one of the properties we look at with functions is symmetry. That's an important property. It's an interesting property. Some functions are symmetrical. Some functions are not symmetrical. By the way, what does origin symmetry mean? Is if we were to take, let me do this way. If we were to take a line, a diagonal line through the origin, could we fold it around the origin and be symmetrical? In this particular one, no, no, we wouldn't have that. So some functions do have that sort of symmetry if you were to sort of fold it that way. Okay, so let's see some more properties. Find the open interval for the following function is increasing, decreasing, or constant. So uh, that's one of the other properties is we want to know the intervals at which the graph itself, the line or the graph is rising, falling, or flat. Rising, falling, or flat. So let's take a look at this one right here. This is a horizontal line. So are there any, let me go down. So are there any intervals for which it rises? No, it's a horizontal line. And are there any intervals for which it's falling? No, it's a horizontal line. So the whole thing is constant, not rising, not falling. It's straight across. This is a horizontal line. So it just stays flat all the way through. So go down to the interval, go down to the choices. Is it increasing on one interval? That means it's just doing nothing. Increasing on one interval means the line is doing this. It's just going straight up and never stopping, or doing something like this. That would be increasing on one interval. Increasing. Do you see what? So it's going up and never coming down. So it would look like one of those two things. Our graph, our flat line, does not look like that. So no. Decreasing on one interval. That's the opposite of these. That's the opposite of these. So decreasing on one interval means it's decreasing all the way through. So it could look like that, or it could look like this. So it's just always decreasing all the way through. Ours doesn't look like that, so no. Is it constant on one interval? And what we mean by one interval is mean the whole way through. Just one interval, the whole way through. And yes, ours was. Constant means flat. And this constant on one interval means constant all the time. All the time. So yes. So looking at the other ones, increasing on one interval and decreasing on another one. So that could be this, increasing on one, decreasing on another, or it could be this, something like that, or this, something like that. That's what increasing on one interval and decreasing on another means. What about increasing on two intervals? What would that look like? That's sort of an interesting one. So it's got to go up, down, and then up again. Because it's got to increase on two different intervals. So it's got to go up, and at some point it's got to come down so you can go back up again. So that would be it, or you could do something like that. And then how about decreasing on two intervals? Well, that's just the reverse. It's got to come down on one interval and then go down on another interval. So it look like that. So that's what this is talking about. So one of the properties we're interested in is symmetry. Can you fold it and get the same thing? And then also, what are the intervals for which a graph is rising, falling, or remaining constant? So let me pause here. Do you see what we're talking about when we say increasing or decreasing? We're actually talking about the shape of the graph rising and falling from left to right. Any questions on that? Isis, I'm seeing your question about the semester. I think the first week of December is our last full week of regular instruction like this, lecture. The next week after that, I think, is finals week. Okay, any questions on increasing, decreasing, any of that stuff? So this one was constant. And so then you want to give the interval itself. So in this one, the interval, so it's the same thing as what they're talking about is what's the domain. When they say what interval is it increasing, decreasing, or constant, they're asking about the domain. So what is the domain for this interval? And you would say, because that's one of your review test questions. What's the domain here?
Negative infinity to infinity because they have arrows.
Mm-hmm. So the only interval is negative infinity. So you have to use your keypad here. Negative infinity to positive infinity. So let's see. Did we get our answer right? Yeah. So you will want to be prepared to do the interval notation as well. So let's try a similar one. See if they give us something different. No, they don't. Try a similar one. Okay, they really like, so they're not going to give it to us. So here we go. What is the average rate of change? So, okay, this is interesting. What is the average rate of change? That's another thing that's curious. But the cool thing is, you already know the formula. You already know the formula for the average rate of change. You're actually going to be tested on it tomorrow. The average rate of change is the same thing as saying the slope. But the reason why they use the phrase average rate of change is because slope is only for straight lines, linear functions. If you're in a nonlinear function like this, not a straight line, it's average rate of change. And all that means basically is what's the slope of the line that connects the two dots? What's the slope of this line? What's the slope of that line? That's what they're asking about. Is what is the slope of the line that connects the two dots? So what's that formula? Tell me what the formula is for slope.
Y equals mx plus b.
That's the slope-intercept formula. That's the equation of the line.
Right. Is it, I'm sorry, y2 minus y1 over x2 minus x1?
Boom. That's it. That's the same formula for average rate of change. Same exact formula. So they're telling you from x1 of 4 to x2 of 7. Okay? So so we know the x values. We know the x values here. They're telling us, I want x1 and x2 of this. So my x2 is 7, my x1 is 4. What goes in the top for this problem? What's my y2 and my y1? So let me start with, what's my
N-
y2? What's the
9,
y2 associated with an x2 value of 7?
9.
9. Let's see. Yes. Boom. We're given the ordered pairs. So this is 9 is definitely indeed my y2 value because it's paired with the 7, which is my x1 value, x2 value mean. And what's my y1 value?
11.
11. And so then you just find that slope. So they want the slope of the line connecting those two dots. That's what they want. So then do the calculation. Looks like it's what, negative 2 over 3? That's it. And so they want you to write it as an integer or a simplified fraction, no decimals. Any questions on this one? Any questions on this one? Average rate of change just means find the slope, y2 minus y1 over x2 minus x1. And so two word pairs. So let's see. Okay. Skip. Okay, determine if the following has x symmetry, x-axis symmetry, y-axis symmetry, or none of these. Okay, this is a little bit of a tricky question. When you have a function, okay, let's do it this way. When you have a parabola, x squared, that's the key feature here, the squared. So when you see squared, you should be thinking all the time, no matter where, if you see square as the highest exponent, you should be thinking parabola, parabola. And what is a parabola? That's the u. That's the u. Okay. Now this is the function. This is when x is squared. This is when x is squared. But in our problem here, x is not squared. What is being squared? It's the y. Because the y is squared, what happens, it's still a parabola, but this one is a sideways u. So this is when the y is squared. So this would give us this graph. So if we were to take a look at it, would it have y? So now we can do it. So put it on an xy axis. Does it have x-axis symmetry?
No, it doesn't go over the x-axis at all.
Oh
Wait,
wow. This.
no, it does. It does.
Yeah. Let me do this.
I'm getting confused. Sorry, it does.
So it's this. Oh, actually, it's not. I'm sorry. That's not it. Let me change it up. It's actually this. What is it? Let me do this. Yeah, it's this. It actually is that. So when you fold it vertically, is there symmetry? No symmetry. When you fold it, there could be. Okay, but when you fold it horizontally, no symmetry. So it looks like it's a none of these. There's no symmetry there. There is symmetry, but there's not symmetry about the x-axis, the y-axis, or even the origin. There's a different kind of symmetry. It's just not one of these four options. So folded along the y-axis, is it symmetrical? No. Folded along the x-axis, symmetrical? No. Folded along the diagonal, still not symmetrical. So it's none of them. It's none of them. But the key
So,
here, the takeaway is when you see the y squared, you're dealing with a parabola. And they may throw this to you. I don't know. But what if they gave you this? X squared plus y squared equals, I'm going to do change it, positive 7. If you see both x and y squared, doesn't always mean it, but usually means it's either a circle or an ellipse. But either way, it's a closed loop when both x and y. So it's either a circle or an ellipse when both x and y squared are squared. But if only one of them is squared, it's either a u that goes up, that's x squared, or it's a sideways u, that's a y squared.
Professor, okay. I was about to be like, could you check your answer? Because I used Desmos to graph it, and it's reflecting over the x-axis.
Okay. Yeah. I could be wrong. But the reason why I did that is I'm sure I'm wrong. That's okay. Because I was doing something else. I was use Desmos. It's better than me in graphing. So yes, go with that. Okay. Okay. So what I'll do. So we're on 4.2. What I'll do is I'll pick up and finish 4.2. But I think you have enough. You're armed with enough information. Use Desmos for graphing. You're armed with enough information on 4.2 graphing to do that. So we're going to pick up then with combining functions and doing inverse functions on Monday. We're going to be able to get through that in one because you already know the information. It's just a matter of kind of putting it all together, and that'll mean we can start looking at the remaining stuff. Kind of the remaining stuff. We'll get as far as we can. We may or may not get through all this, and we'll just decide what we're going to do about that. But we could probably get through all of it. Anywho, so the test will become visible later tonight. Do it tomorrow, but if you do it over the weekend, that's fine too. But tomorrow is going to be the time that I set aside for it, and then we'll pick up with this stuff on Monday, and that way, if you have Thanksgiving, the one reason why I want to do the test on Thursday is because if you have Thanksgiving plans, I don't want to interfere with those. I don't. So I know kids are out, all that stuff next week, and I just don't want to interfere with it. And then doing the next week is just too far along, I think. So that's why I chose Thursday. So you'll see it. Do the test. I would encourage you to do it tomorrow. But if you don't get to it till the weekend, that's fine too. And let me know if you have any questions. I'll be happy to help out. And Jackie, I'll get to your question tonight. Okay? Well, I think she
I
might.
have a quick question before you go.
Uh-huh.
Can you please upload the recording for today so we'll have it if we
Mm-hmm.
need to go back and check it for this lesson?
Yeah, definitely. I'll do that.
Okay.
It takes about an hour for it to process, but I'll get it up there for you, okay?
All right. Thank you very
All
much.
right. Sure thing. Hope you have a good night.
All right, you too. Bye-bye.